Welcome to our Python programming adventures. Today, I'm diving deep into the world of XML, creating and parsing XML documents using Python. Whether you are a seasoned coder or just starting out, this tutorial will guide you through the fundamentals of working with XML in Python. Creating and parsing XML documents in Python is a valuable skill for managing and exchanging structured data. In this tutorial, I will cover the basics of creating XML documents and parsing them using Python's built-in XML module. Let's dive in. XML or Extensible Markup Language is a markup language that stores, transmits, and reconstructs data. It defines rules for encoding documents in a format that can be read by both humans and machines. It is built on tags, and you can define your tags for your needs. It's also usually used for descriptive purposes. XML is a software and hardware-independent tools that supports information exchange between computer systems, such as websites, databases, and third-party applications over the internet. Here is an overview of the tools that used to construct XML documents. Before you get started, let's take a quick look at the tools you'll be using. There are two main libraries for XML document generation in Python, xml.e3.elementtree and lxml. Those are powerful and easy to use, but they offer slightly different features and performance. First up, we have the xml.e3.elementtree. This library provides a simple and lightweight API for constructing XML trees. Let's take a closer look at how it works. Now I'm going to show you the demonstration how to construct XML using these powerful libraries using Python. Let's get started. To do this, first import the libraries xml.e3.elementtree. And we shorten this as a short name like et, that is easy to use and write the names instead of using the long name of the library. XML document is a tree-like structure, so every tree has root and child elements. So we first construct the root elements of the XML documents. So we use element class in the xml.e3.elementtree module, and we pass the name of the root element, for example, data. And so every root may contain the child elements. So now I'm going to create the child elements under this root element. For example, the child element in this case is country, and I'm going to use et.subElement class. And this class is going to take two arguments, that is the root and the new element name, the child element name, for example, country. So every child may contain the attributes or the values. So now I'm going to create the attributes of the child class country. For example, country dot text. Text is an attribute that used to store the text of the, for example, the name of the country under this element. And a root element may contain more than one child element, so I can define one more child element in this root element. So I can copy this and change. So this, for example, city is A, and I can change the name of the child, right? So the next step is just create an XML tree structure. So to do this, I'm going to use ElementTree class. And I just pass the root class into this ElementTree class as an argument. And finally, let's write this tree structure into a file. This is the write function, and pass the name of the file, for example, output.xml. And now run this code and let's see the output. All right, output.xml is created, and So this is a simple example how to create an XML document using xml.e3.elementary. So I just started by creating a root element, then add child elements, and finally write the XML to a file. It is straightforward and easy to understand. Next, let's talk about lxml. This library offers additional features and performance improvements compared to xml.e3.elementary. Let's see what it can do. Let's import the e3 from lxml, and to create this, you can use the same process to xml.c3.elementary, but lxml offers additional features or functionalities like XPath support and schema validations. So I can just copy this and paste here. I don't need to write everything from the scratch because the process is the same, and I can change this et to elementary. Now change this to 2 to identify which XML document is created using xml.e3.elementary and which one is created by lxml. Alright, let's run this again and let's see the outputs of the XML document which are created by using the two powerful libraries using Python. And let's download this and let's see the structure of the XML document. All right. So as I have said, we can use additional properties to prettify the structure of the XML documents in the second one, because this provides additional functionalities like pretty print is true, and let's see the output. All right. Using the second one, that the structure is well defined, and the root element is data, and the sub element or the child elements are country and city. But the first one is just it is not well formatted. So the second one just provides additional functionalities like formatting the XML documents, and the other especially schema definition or validation is provided by using lxml, and performance is better than the one we used this one. But the first one is the most commonly using library to parse XML documents, because XML document is available across the internet. It is preferable to store large volumes of data, text data, and you can. It also contains unstructured data, so we are going to just parse that unstructured data and transform into structured formats for data analysis. Now that we have seen about the two libraries in action, and that compared with the features they provide us, and why both are excellent choices for XML document generation, it is essential to consider your project's specific needs. That wraps up our beginner's guide to creating XML documents in Python. I hope you found this tutorial helpful and informative. Remember to explore further on your own and experiment with these libraries. Now that we have mastered creating XML documents, it's time to unlock the secrets of parsing them with Python. Parsing XML allows us to extract valuable information from structured data, opening up a world of possibilities for data manipulation and analysis. Before we embark on this XML to data frame adventure, let's quickly grasp the fundamentals. XML, or Extensible Markup Language, serves as a versatile data format for storing and transmitting information over the internet. Meanwhile, Python data frame, a cornerstone of the Pandas library, empowers us with the tabular data manipulation process. But why bother converting XML to Python data frame, you may ask? Well, by harnessing the data frame magic, we unlock a treasure trove of data manipulation capabilities, from filtering and storing, sorting to merging and visualization. Imagine we have this XML data, snugly packed with juicy data about books. Our mission is just converting this XML goodness into a Python data frame. For I shall guide you through each step of this exhilarating journey. So this XML document is a more complex example of XML data representing a library with books. So the library is a root element, and the book is the child element for the library element. And this including additional information such as author's first name, last name, January, price, publication year, and publisher. All right, let's dive straight into the code and navigate our way through the XML to data frame conversion process. The first step is import the necessary libraries. So in this tutorial, I'm going to use the pandas library to transform the extracted or converted data into tabular format. So I should import that library, import pandas as PD. And we also import the ElementTree. That is very powerful library for parsing any XML documents. All right, with our trusty libraries by our side, we are ready to embark on this XML adventure. So the second step is parse the XML file. Now let's parse the XML file using ElementTree's parse function. This will give us an elementary object to traverse through the XML structure. et.parse from ElementTree, and we pass the name of the XML document name or file name. For example, in my case, it is book.xml. It's going to just parse this XML document, and let's define and obtain the root element from this XML document. In this case, the root element is library. All right. And to check that, let's print this root and let's run our code. All right, the library element is parsed, and it is just returned as an object, and we are going to iterate through this object because this root element library contains the child elements. We are going to iterate through this and obtain all the child elements through this iterative process. And let's comment this because this is not necessary right now. With the XML parsed and the root element captured, we are ready to delve deeper into the XML reaches. Okay, the third step is extract the data. Here comes the exciting parts of extracting the treasure from our XML chest. Let's iterate through the XML tree, plundering each book's riches and storing them in a list of dictionaries. So we define a variable book list that's going to iteratively store the list of book data, and we just iterate through book element in the root dot. We use find all. Find all function is very important. That's used to iterate through each element. All right. So this is the root, and this is a child. So there are more than one book element, and I just refer this book element in this iteration in the find function by using quotation dot slash slash book, because this indicates that there is a root that element before the book, and I am looking for the book elements, and I'm going to iterate through this book element and obtain all information is under this book element, because in the book element there is a title element, outer element. There is also a sub element in the outer, the first name and last name, generally price, and all the information can be extracted from this book. And this book element has an ID attribute. So inside the element, there is an attribute ID. So I'm going to extract this ID value because this identifies each information. And I'm going to define a new dictionary element that stores all the informations. and book dict ID, the IDs of the book, and in this case, I'm just called book element dot get dot ID. This is the book element, and just obtain the ID, the values of the ID for the book element. And now we also iterate through the child element, because we have a child element in the book, the child element in book element. And in this case, there is a dictionary dot child element dot tag. I'm looking for the tag in the child element. If there is a tag in that child element of the book, so if the author has the child element's first name and last name, it's going to just obtain that tag, which is the child element dot text attribute used to extract the text, which is contain that text. For example, the title, just obtain the text. This is the text attribute. And when the tag is extracted in that child element, it's going to obtain the text through the text attribute. And finally, let's store into book list by appending the book dict. So every dictionary going to append into a list, and each stores that information. For example, let me print out the book list and let me check. Now let's print this and let's see if the book information is extracted or not as a list of dictionaries. Yeah, the IDs, the title, everything is extracted, and each list contains the dictionaries of each book. So each book contains information about the title of the book, the IDs, the January, the price, publication year, the author's first name, last name, and so on. So with our load in hand, a list of dictionaries containing book data, we're one step closer to our data frame designation. All right, the next step is just convert to the data frame. So, and finally, let's convert our extracted data into a glorious data frame using the pandas data frame function. Browse yourselves as the XML data transforms into a tabular format. To do this, we can define the data frame, and we use the pd.data frame, and we pass the list of dictionaries data into this data frame function. And finally, let's print the df, which is the data frame, and let's see the data is transformed or converted into the tabular formats. All right, so the data is just converted into the tabular format according to this data frame. The IDs of the book, the title, the publication year, the publisher, and so on. So this is what you called transforming or converting any XML data into the pandas data frame, because pandas data frame help us to read our data in tabular format, rows and columns. All right. So, and there you have it, folks. With this code snippets, you're well equipped to conquer the XML to data frame conversion challenge. So grab your keywords and embark on your own data exploration journey. In conclusion, converting XML to Python data frame might seem like navigating uncharted waters at first, but armed with the right tools and knowledge, you will breathe through it like a seasoned captain. So hoist the sails, pillow data adventures, and may your data frame journeys be as prosperous as the tales they tell. I hope you enjoyed this short video tutorial about converting any XML document into Python data frame. Feel free to subscribe, like, share, and write comments below. Thanks for watching today.